Hi, I'm Nicole Morin.
I'm Nyla Arcega.
And
I'm Mitch Russo.
And this is our math project on the vertex form of quadratic equations.
So Nyla's going to start off.
This is the vertex form of quadratic equations. F of x equals a times the quantity of x minus h squared plus k. This is primarily used to find the vertex. A affects whether the graph opens up or down, as well as the width of the graph, narrower or wider. The combination of both h and k affect coordinates of the vertex. K affects the y-coordinate of the vertex, and h affects the x-coordinate of the vertex.
And that's just a brief summary. We're going to go a lot more in depth on all of that stuff there.
This is the parent function of quadratic equations. F of x equals h squared, or x squared. The vertex of the equation is at the coordinates 0, 0. And as you can see on opposite sides of the vertex, there's symmetry. When you square -1, you get 1. When you square 1, you get 1. Hence why on either side, they're on the exact opposite of the y-coordinate.
Yeah. Good to go.
Okay, this equation is a variation of the parent function where f of x equals 2 times the quantity of x plus 0 squared. And when the absolute value of a is greater than 1, the graph becomes narrower than the parent function. And
Seeing as though 2 is greater than 1, the graph will be narrower, as seen here.
okay, and you'll notice on the sides the points, they increase at a faster rate, which causes the graph to be narrower as well.
Yeah, they increase faster than the parent function we just showed.
Okay, and the point is still at 0, 0, the vertex.
The origin.
The origin. 0, 0.
It's still
Oh yeah.
And it can also be simplified to look more like the parent function if you remove the zeros and make it 2 times the quantity of x squared, because the zeros don't really matter.
Hey look, it's not quite a parabola, but it's kind of like a trapezoid, rectangle, parallelogram kind of thing. Anyways.
Okay, this is another variation of the parent function where f of x equals 1/2 times the quantity of x squared. In this graph, the absolute value of a is less than 1, so that makes the graph wider than the parent function. You also notice that because a is less than 1, the coordinates increase slower, which makes the graph wider.
And as you can see, the vertex is still at the origin 0, 0 because h and k have not changed.
Hey, so I finally joined us now, and this is our next transformation of the parent function, which is f of x minus 1 times the quantity of x plus 0 squared plus 0. Obviously you could take off the zeros and it would just be minus 1x times x squared. But this demonstrates that when a is less than 0, the parabola opens downward. As you can see, our vertex still hasn't shifted because h and k still have not changed, but now the parabola is opening downward due to the negative in front of the entire equation in place of a. And all the y values come out negative because everything, in this case, because our vertex is still at the origin, is going to be below the x-axis. Moving right along. We have our next transformation, which is 2 times the quantity of x plus 0, or 2 times the quantity of x squared, plus 2. This is now going to show the change in k, because k is no longer 0 but 2. And then it shifts, that this change shifts the vertex along the y-axis. So now the vertex is no longer the origin, but 0, 2, because k is 2, which takes the place of the y. So, and since a is also 2, I should mention the graph is going to be a little bit narrower than the normal parent function. So that's why it increases slightly more, but the point of this one is really that the graph is shifted up 2 points because k has changed now. And this is the final transformation we have, which is just f of x is equal to x plus 2 squared, the quantity of that, plus 2. And as you can see, both h and k are no longer 0, which is why the vertex does not even have a 0 at all in it. Our vertex is actually negative 2, 2 now, because 2 is k, and h is 2, and the quantity of what is in those parentheses with h needs to add up to 0, which is why it comes out as -2 and not 2. Because h plus x need to come out as 0. So -2 plus 2 comes out as 0. Therefore, the x-coordinate is going to be at -2. And as you can see, just like the parent function increases by the same rates, but the origin is shifted up 2 and over to the left 2. And here we are again with another lovely equation. There's Nicole over there, and me, videotaping. So here's our equation. F of x equals the quantity of x minus 2 squared minus 1. Now we're going to give you guys a chance to interact with this one a little bit. So the first thing I would ask, since, oh, this is vertex form, which I'm sure you guys can recognize, are a times the quantity of x minus h squared plus k. There it is right there, all of it, which we've been over. So now, first question would be, what is the vertex? So now you're going to try to figure it out, and you didn't just see that glimpse of the first coordinate. And you're going to look and you're going to see that k is -1. So you're going to figure out that the y coordinate of the vertex is also going to be -1. And then hopefully you're not going to think, oh, h is -2, so my x coordinate is -2, because the quantity of these two when added together needs to equal 0. So to make that equal 0, your x coordinate needs to be 2. 2 plus -2 equals 0, which you guys all just figured out. Now we're going to come down here and start plugging stuff into a table, because that's our next step before we can graph. So there's your x coordinates. So what would be the y coordinate? That would go with -1. You're going to go in and you're going to figure it out. You're going to do -1 minus 2 is -3. You're going to square that. -3 times -3 equals 9. Minus 1, and you're going to figure out that, oh my god, it's 8. And then you're going to keep going down and down. You're going to get to your vertex. And then, what are you going to see?
Symmetry!
Woo! Look at it, there it is. Yeah, there's the symmetry. So then you're going to come over here and you're going to graph it. Oh, there's a magazine there. So the vertex would be estimated right where? That's right, right about there somewhere. That's what we're going to guess. And oh, pretty close right there. That's our 2, -1, and then you see all the points we graphed before. And yeah, that's about it. I'm being mocked. So that's our project.
Bye, Mr. Crowley.